Welcome to engine oil for the Airbus A320 family. All right, what is the objective? Obviously engine oil, we're talking about lubrication of certain components, and we'll be going over some of those and just what makes up the lubrication units. Remember, keep in mind every time we're working with anything under pressure, safety has to come first. So we're just going to go over some safety tips along the way. You will become familiar with the general concept of the supply circuit and the scavenge circuit, also with the components involved and the locations of them. And I've mentioned this before, I don't know how many times, but 3 aspects to any system is QTP: quantity, temperature, and pressure. All 3 of those aspects come into play in regards to the integrity of the operation that's involved. So we want to make sure that we do have the right quantity of oil and as well as the right temperature and pressure at various points. Okay, because we can't really afford to play Russian roulette when it comes to the aircraft and maintenance with it. There's going to be a test, of course, associated with this subtopic, and I'll be mentioning the questions along the way. In fact, I may just introduce a little bit of that to you here in the beginning, just to get you kind of get your feet wet, so to speak, with the questions and what to expect as I'm explaining the material. So please take notes. All right, safety working around jet oil. And you probably already know some of the problems that have come from putting, and I know I'm switching a little bit, but the 2 fluids you have are in an aircraft is fuel and oil. And it's very important to ensure that there's the proper oil, for obviously the aircraft. And keep this in mind, the oil itself contains toxic ingredients, so you don't want to be having your skin exposed to it for a long time. You want to make sure you do wear personal protective equipment, whatever is supplied to you at your MRO, but also you may want to definitely make sure you read what's in the safety manual, or I'm sure you have safety meetings to make sure that you keep that in mind, because you don't want to have a skin. What happens if you get it subcutaneously, which is under the skin, it can cause irritation, so you need to be careful with that. The other thing too with oil is it can, it's under pressure, so till it's not, it can become a problem, a potential danger to you as you're working around these components. So kind of keep that in mind. Make sure your clothing protects as much as your body parts as possible. Okay. You may not care what kind of ingredients are in that jet oil, but there's 2 in particular: tricrystal phosphate and the Nephyl-1 compound. I won't get into the long name on that one because it is long, but that's part of the combination that makes up jet oil. So please be careful when you're working around this. Also, the other thing too is the fumes. You can, when you're around this, you can have the expenditure of fumes from that oil, so you don't want to be around that too long, inhaling that, because that could cause some respiratory issues. Also, all that just goes into your brain, so it's going to be affecting, perhaps you might feel some dizziness, etc. So again, be careful with all of that. The eye contact, of course, they say flush out with water. So if you get oil by accident in your eye or eyes, you need to seek medical attention right away. You don't want to delay anything that comes in contact. Better to be safe than sorry. Don't just brush it off. Okay. All right, that's my thing on jet oil. And since we're going to be working and talking about it, right, or you're going to be working on it, and I'm going to be talking about it. Indications related to oil. Okay, remember what I said about quantity? We want to make sure there's enough oil in the tank. The oil tank, by the way, is located on the fan case of the engine at the 8 o'clock position. So there you have your typical sight glass to kind of see where that level is located, or where that level is as far as the oil in the tank. You also have a supply pump that's going to move that oil out of the oil tank and get it through the circuit. The other thing too, there's an siphon, and that's just making sure, again, making sure that you don't have this collection of oil back in. How much is enough? So back on quantity, I mentioned about the level. Do follow, of course, what's in the manual as far as the quantity of oil, minimum quantity that's necessary, and then also whatever is necessary for that, you know, for that flight, for the aircraft to fly. Obviously, that's not going to be exact, but it's going to be that minimum quantity plus, you know, extra. Okay, so be aware of that. The indications that you have in the cockpit. Okay, you're going to have also, you know, you're going to have that indication as far as the quantity with the oil. That's going to be in there. Of course, once you do the check on the oil level, I mean, if it's too low, you're going to need to fill it. After you do that, though, you need to put that warning tag, you know, in the cockpit that, you know, it's, you know, to just let people know it's not to be operated. So there's that. Also the oil filter. Of course, there's filters throughout all systems. And here, you know, I know if you got through already the fuel part of the fuel lesson, if you know, just like we have to have, you know, ice-free, clean fuel, we need to have also clean oil and at the right viscosity, etc. So this is all, you know, the oil gets affected by temperature, right? So it's important that that oil be in the condition that it needs to be. In order to be effective with the lubrication. The oil filter is helping with part of that. So there is an oil filter clogging indication that lets, you know, it gives a warning if there's a filter clog. So we'll make sure we can have that filter working. Okay. This is, I'm just kind of giving you a brush stroke or a helicopter's view on just, you know, the oil tank, you know, what it has there as far as indication with the quantity. And like I said, we're going to get to more of the temperature and the pressure and some of the components involved with that, just to make sure again that the oil is where it needs to be. All right, so let's go ahead and get into this. What components, you know, make up the lubrication system, and what do we need the lubrication system for? Okay, well, you have a lubrication system. And by the way, just like in other systems as well, even in hydraulic systems, it's separated and basically it's isolated. Okay, it doesn't come into contact, you know, with any other, or gets mixed with any other system or subsystem. It's pretty much in its own little world. So that's, just think about that. It's its own mechanism, if you will. And the, you know, with the lubrication system, you know, what do we need to lubricate? Okay, what's our objective? We have oil in the oil tank that's going to lubrication units, kind of like the middleman, saying, okay, I have these, you know, I've got filters, but I also need a way to distribute that oil to what? Okay, what's our end result? Our end result is getting that oil or the lubrication to the components. In particular, we're talking about the engine bearings, the gearboxes. But not only is it for lubrication, we're also needing to cool some components, and that's another function of the lubrication, okay, that we have here. So we have the distribution of, you know, of the oil that's going through nozzles, and then, you know, we have, after that oil gets distributed, let's say for example the accessory gearbox. Then what? You know, we have some of that residue, you know, obviously, you know, its lubrication has done its job, but now we've got to return some of that oil. So that's that other circuit. We have number one, the supply circuit, okay, meeting that objective I just mentioned. And number two, we have what's called the scavenge circuit. And that's basically grabbing a hold of the, you know, remaining oil from those areas where we needed that lubrication and bringing some of that back into the oil tank. And the condition that the oil needs to be in, because after it's done its work, because anytime there's work, there's heat that's expended, right? If you remember from the A&P days, if you have your A&P license, you know, anytime work is expended, you're going to have a byproduct of heat. And that's exactly what happens with the oil after it's been used up, if you are used. Some of it's used up, because there's some evaporation with that because of the heat. But now you have hot oil, and we don't want to have too hot of oil going back into the oil tank. So we've got a process where or a circuit where we're going through servo heaters, the oil fuel exchanger, heat exchanger, to get some of that dissipate some of that heat before it goes back into the oil tank. Okay, so that's kind of giving you a kind of a helicopter's view, pretty good view actually, of kind of the chain of events and the objectives that we have with those two different circuits. And that's what we have. All right, and of course with the lines that we have, the lines are obviously going from the oil tank. And by the way, from the oil tank you've got, like I said, you got filters, because you've got to make sure you have filtered oil along the way. But then you have those tappings in the line, because why? We need to get, we need to get the oil distributed to the different areas where it's needed. And therefore you have those. You have pumps, different pumps throughout the circuits. You have one supply pump I just mentioned earlier in the oil tank, because you're going to have, you're going to need to get that oil moving, obviously, and then getting it to be pressurized. Then you have 4 scavenge pumps, okay, to bring that oil back. Okay, this is all under pressure, and you have to have a certain amount of pressure. Roughly, it's about 30. I would say roughly about 35 psi of pressure that oil needs to be going, or be at, running through the line for distribution to the nozzles that go and spray, to those components that need it. For example, engine bearings. Okay, your pumps that I mentioned, whether it's your 4 scavenge pumps and the supply pump, all of those are the same type of pump. I don't know. There's so many different kinds of pumps, but just so you have an awareness of what kind this is pretty standard, actually, Durotor type positive displacement pumps. There's different kinds of pumps, gear pumps, etc., etc. This one's just, pretty standard for the application, in this particular application that we're talking about. Okay. All those pumps are actually driven by a drive shaft, okay, that's running and being moved by the accessory gearbox. Okay, so just so you know, how many scavenge pumps do we have? 4. And how many supply pumps do we have? We have 1. Okay, I'm going to jump a little bit. Not really jumping, but I just want to make sure I cover some of the practice questions, which, by the way, hint, hint, you probably will see on the test. And there could be between 20, well, more likely probably more than 20 questions in all, as far as, any of these subtopics, but this one could be between 25 and 30 something questions. So be prepared, take notes right now. Question to you, what does the lubrication unit consist of? Okay, you have 2 choices. One, is it 3 positive displacement pumps or 5? Okay, I just mentioned to you it's 5. Right, it's 1 supply pump and 4 scavenge pumps. Okay, number 2, where is the lubrication unit located? Okay, I mentioned it was on the fan case, but I will mention, obviously on the fan case, but is it the right side or the left side? Okay, it's actually the right-hand side of the accessory gearbox, front face. And how many servo fuel heaters are part of the lubrication distribution system? Okay, I haven't mentioned that yet, but again, I'm throwing it out there. There are 0. Okay, how many servo fuel heaters are part of the lubrication distribution system? It seems like a trick question. I don't mean to trip you up. These questions are not designed, by the way, to trick you. You do need to read the question, but this is not going to be too complex. I just want to have you just basically to raise your awareness. Okay, so when you walk away, you have more familiarity than you had before. Okay, that's the bottom line. That's our objective. Describe the sequence of how the pumps take in oil. Okay, I'm just going to tell you here, there's an initial half cycle, and when that volume increases, okay, then you have that increase, what creates a partial vacuum when it does. And it's basically, when you're causing a vacuum, you're creating a suction effect, and that's what that's about. And that's what happens in that first part. So that's the answer. That's the answer there. So, and I'm just again mentioning a few things here for you. All right, so let's go back to our thought here on the oil tank where everything is starting, because that's where the oil is located, and that's what we want to get from point A, the oil tank, to B, point B, which is going to be several places actually. All right, so here, what do we have? What's the general idea, and what parts do we have in this thing? Well, for one, we have to have filters. There's different filters. We also have a clogging indicator transmitter, because we want to make sure that that is being indicated in the cockpit, right? So we need to have that clogging transmitter when the oil filter is indicating it's clogged. We want to make sure that we know that. And there's also the bypass valve. You got a pressure gauge also, and a temperature sensor. And we'll talk a little bit more on the temperature part as well as pressure. All right, so what do you have also? Remember I mentioned the anti-siphon. You have the supply line. Remember, it's going from the oil tank, okay, so that it can get to the lubrication units to get to the distribution nozzles. That supply line. Well, in that supply line is installed a device, and that device there prevents the tank from basically draining into the gearboxes when the engine's shut down. So it's a protective measure. So that anti-siphon, just think of it as a protective device in the circuit. And that's usually, and like I said, that's just, when the engine is shut down, so it doesn't drain the tank. Okay. Now the temperature sensor and pressure switch, you have a signal that's used by the ECAM system, and that's to obviously give the indication for the filter clog, and then also a temperature sensor. The temperature sensor is going to be on the filter housing of the lubrication unit. Okay, you have that lubrication unit I mentioned before. And by the way, what you're seeing here on the diagram, there's a supply area and a supply and a scavenge area. It's part of the lubrication unit. And so you have this, and basically on here with the lubrication unit, this is provided by the oil that's bled from, obviously getting from the supply pump discharge circuit, and that's going to enter there and go, through the conduit of the drive shaft. Okay, but just kind of mentioning the sensors that you have along the way is the pressure switch, and you have a temperature sensor. Okay, and then that oil clog transmitter, transmitter, so it can give that indication or message to the ECAM. Okay, and just to mention again what what the oil is used for, it is lubricating the engine bearings and the accessory gearbox, as well as the TGB, okay, your transfer gearbox. Now, one of the problems that that is inherent with oil, if you haven't or don't remember, if you haven't had a lesson on oil, the whole thing's fascinating actually. But anyway, that in itself, just talking about oil, is fascinating. Or if you're even with hydraulic fluid as well, just as a topic by itself is fascinating. I mean, oil's oil, right? But there's just, the reason I mention that is because you have the danger of air being mixed in the oil, and that's not what we want. So there is a separator, a device, component to basically separate the air out of the oil, and just basically what they call aerating. Well, that's what aeration means. It means, removing getting that air out. Okay, so just so you know, you do have that component as part of it. The other thing too, the oil can accumulate or attract little debris. Could be little metal chips, little metal particles or particulates that come from just being around the gearboxes and the engines, and we don't want to have that either. So another part or another component of that whole lubrication system circuit is the magnetic chip detectors. So you have those as well, being able to attract magnetically the metal away from that oil and out of the oil. All right. So, and just kind of there's that. Then the other thing too that you have on the scavenge circuit is your plugs. There's basically screens with these plugs, and just so you know that those are there. You also have the fuel heater, your main oil fuel heat exchanger. The servo fuel heater, just kind of a side note, it's not really part of the lubrication. It's there, but it's not considered part of the lubrication system. Now the oil fuel heat exchanger is considered part of it, and they serve the same purpose. I mean, both of these components in that circuit are there to cool the oil before it goes back to the oil tank. Okay, so if you're ever asked a question, you know, what's the function of the servo heater or the oil fuel heat exchanger, it's to cool the oil, make it less warm before less hot before it goes back to the oil tank. Okay. All right. And I mentioned also, remember, about the air oil mixture. You've got to, there's that aerator to separate that out. You also have that magnetic chip detector that will be positioned in that system as well to attract those little metal pieces. Okay. All right. And again, I don't really want to belabor talking about that. It's the concept is simple as far as what it does. Okay. The details as far as the filters. There's different kinds of filters that are used. Just know that there are different ones. Make sure you do pay attention to the serial numbers, obviously, on them when you're switching them out, because some of them look very much alike, and you might mistake one for for another, and it's not really the same. And the reason why it's not is because they're rated differently, right? I mean, you probably know that, but filter ratings, there are so many different ratings in microns for these filters. And again, they look the same. There's a filter, but what is it rated? So you want to make sure that you're replacing, like for like, not by visual, but by serial number. Okay, visual meaning just you're looking at the canister, or you're looking at, basically the cylindrical filter. There it is, or whatever, and you're like, oh, that looks like the one I have it, in the warehouse to switch out. Well, it's not going to work. It may fit, but my point is you want to just pay attention to things like that when you're, if you need to switch out any filters. Okay. Also, part of the system we have is the sump. You've got the sumps. You also have the sump vent subsystem, so you're getting some of the air, or that, basically the air out. And so you have that. Basically, the sump is vented to remove the air which enters there. So that's all that's for. I mean, just like your vent surge tanks in the fuel system, it's just a way to really get some of that out, and there's those vents for that purpose. Okay. All right. The other thing too that you have, I know I mentioned before, is the I said temperature sensor, and you also have the oil pressure switch. There's a transmitter, because in the cockpit, right, we want to know what's the oil pressure like. We need to have it at a certain level coming out of the tank. Remember I said roughly about 35. There's a range there, but don't get hung up on numbers. The main thing is looking at your indications and where those indicators should be on the on the ECAM. So, but it really is somewhere around 35 psi. The oil pressure transmitter, it just enables that oil pressure within the system to be monitored, obviously, and so that it can be showing up on that ECAM. Okay, so you have that. The low pressure switch. Okay, it's your low oil pressure switch. That is obviously there, to let the crew know that they're low on oil. Okay, and just to note on the flow, when that pressure, that oil is pressurized, you have it going to the forward sump, because you've got different engine bearings, right? And if you recall, if you've taken a class in power plant, I'm talking strictly on the engine construction, there are diagrams to show the different numbered bearings and where they're located, and you know, what you have. So with the forward sump, you've got bearings 1, 2, 3, and the aft sump you have 4 and 5. And you also have the accessory gearbox that it goes through. So you have that flowing, you know, going on there to have the lubrication of those engine bearings, okay, as well as the AGB, your accessory gearbox, which then after that goes into the TGB. That's your transfer gearbox. All right. All right, so we have supply pump to pressurize the oil to go to the engine bearings, to go to the accessory gearbox and the transfer gearbox. Well, now we've got to remove some of that oil, getting it back out. And here's where we come into the 4 scavenge pumps. So you have 4 scavenge pump elements that take away that oil from the engine bearing sumps, okay, and the gearbox, and it's going to be returning that back to the oil tank, okay, and it's got to cool it. So just remember, it has to cool that. Okay, I'm going to throw in a few test questions because I didn't want to be remiss with some of these and not mentioning them. But all right, I know I haven't covered it, but here's the test. Here's a question. Okay, what flow rate is created by the supply element at takeoff? Okay, at aircraft takeoff at a normal pressure of 60 psi. Okay, what flow rate is created by the supply element at takeoff? Okay, I'm going to tell you that that's actually 2,495 liters per hour. Just remember that it's a 4-digit, not a 3-digit. So if another answer is only 3 digits, is wrong. It's the wrong answer. All right, it's actually 2,495 liters per hour, roughly. So that's the rate at which you have that flow rate. What's the normal pressure range of the oil? I put it in bars. If you want to convert that to PSI, then that comes roughly to about 35 PSI. The bars are going to be between 2.5 and 2.7 bars, just another unit of measure. Okay, let's how about another one, and then we'll go back to our lesson. What controls the distribution of oil to the demand components? Is it the ports or the spray nozzles? Okay, I kept mentioning about nozzles, so the answer is spray nozzles, right? We have at the distribution, we have the spray nozzles that are going to be spraying in those to the components that need it. Okay, all right. So let's kind of take a back here and kind of go into a little bit more. All right, with the oil, I covered the oil tank. Oil tank has a vent tube. It has the oil level transmitter. Obviously has the sight glass on there, so you can see what the level is. And of course, for filling it up, you have a couple of different filling ports for that. Be aware, and we have our commercial airline pilot on board, probably not intended, by the way, on Operation Aviation. He's one of our instructors. He will share more about that because he's seen it with aircraft mechanics, with line mechanics. To be careful that, after the engine is shut down, you need to let the oil tank pressure calm, just like with anything, right? Give it some time to kind of cool off a little bit, calm down. But that's what you want to do. Don't just immediately, right, open up the cap, the filler cap, and because you don't want to have something come right into your face. There's no such thing as common sense in my book, because what's common to one person could be not common to another, depending on people's backgrounds and experience. So I don't take anything for granted on that note. Just be aware that you want to be careful and give it some time. Don't be in a rush, although I know it can be, you can be under pressure as far as your work and all, but you need to be safe first, or you won't be working if something happens to you. So be careful with removing that filler cap. Okay. Also, don't manhandle it. Okay, I don't need to be saying, if it doesn't move, if there's some, like just normally, if you're trying to actually turn it and it's stuck and it doesn't go, and you're trying to force it, put extra force to it, then something's wrong. Okay, don't put too much into it, because then you're going to damage it, and you don't want that. Okay. And there's obviously indications on the indications, or should I say labels, for you to see, but you know, obviously follow your manual and make sure that you also be careful with the fumes. Remember I said about fumes from fluid. Well, what two fluids do we have in an aircraft? We have the oil that we're talking about right now, and also fuel. And obviously you've got the oil tank on the fan case. You have it there near the engine, so they, it can supply that oil to the engine components. So it has to be physically nearby. But be careful, because after shutdown, you're going to have some fumes that might be there from the fuel. Okay. There shouldn't be a mixture. There should not. Okay, let me repeat. There should not be a mixture of fuel with oil. So kind of be aware if something doesn't smell right, it probably isn't right, and I would suggest you do a little further investigation. Okay. All right. Kind of before you do some things, kind of just a quick thing on procedures. Again, this is just for informational purposes. I'm saying follow step for step at your MRO, follow the manufacturer's publications, etc. on what to do here on the oil, filling oil in the oil tank. But here, you want to add oil. You can do it through the gravity port, filling port, or you can do it through the remote filling port. And there's two ports on the oil tank, and just to know there's both of those. And the other thing too you want to be aware of, just from a visual inspection, is make sure that the O-ring seal is not worn, because if it is, right, it's called a seal for a reason. You don't want to have a leak from that point, and that cap, you want to make sure that that oil O-ring seal is not cracked or broken, whatever. Okay. Okay. All right, and make sure too that the oil tank filler cap is locked properly, because if you don't, you're not creating that pressurized system or pressurized world there. And if that happens, then obviously there's not going to be a good pressure, for operation. Okay, so that's with the oil tank itself, and kind of a little bit about oil pressure. Now, as far as the tank itself, it is holding the oil, so it's important to pay attention to the condition of it as well, and just know a little bit about, its capacity. The maximum, on the tank itself, as far as quick characteristics that we have, maximum unusable oil, no matter at what attitude, because remember, we have different attitudes of the aircraft in which the levels can be different, things can be different there as far as it's holding, but it's 2.5 US quarts, okay, that's max, that unusable oil. And there's just other information about the tank that probably you wouldn't remember, nor is it really that important. But again, just pay attention to the levels, and just know a little bit about the operation on filling. Okay, all right. All right, so we have that, and then also, remember I mentioned about how air can get into the oil, and there has to be a way to separate those two components. Okay, so we do have a separator, and there's an oil in tube port, okay, as part of that, and that there is connected to the tank vent, because that way it can go through the oil, have the oil mixture there and go to the separator. Okay, and that separator is where it separates that air out and then aerates it and gets it actually vented out. Okay. Okay. All right, so let's kind of go a little bit on the pressure. I did a little bit about the oil, the temperature sensor. So let's kind of go over that a little bit, and then we'll. But in the meantime, let's kind of. I don't want to forget mentioning these questions to you, because there's several questions. There's no. I mean, you're going to be wondering, well, gee, that's a lot of material. What am I going to be tested on? All right, so let's kind of cover some questions, get some more ground on this one. All right, which side of the fan case is the oil tank mounted in the Airbus A320? Okay, is it the 8 o'clock position or the 4 o'clock? Okay, I mentioned that before. It's the 8 o'clock position. To install the oil tank, you'll need 2 upper and 2 lower mounts. I know I didn't mention this, but this is part of your lesson here. To install the oil tank, you need 2 upper and 2 lower. Is that true or false? That's actually not true, because you only need 1 upper mount, not 2. There's 2 in the 2 lower mounts you're using, but you only need the 1 on the top. There's only 1 upper one. Okay, what is the normal operating pressure of the oil tank regardless of attitude of the plane? Is it 8/10 of a bar above external pressure or 2 bar above external pressure? Okay, that's actually an 8/10 of a bar. Okay, so 0.8 bar above external pressure. Okay, that's the normal operating pressure of the oil tank. Okay, what is the first thing you need to make sure of before opening the filler cap to the oil tank? Is it make sure the engine is off? Probably that'd be a good idea too, okay, but, or is it B, what I mentioned before? Okay, make sure the engine is off and has been shut down for at least 5 minutes. So I said, okay, give it some time. Kind of rule of thumb is 5 minutes. All right, so that's the first thing you need to do to make sure of before you open that filler cap, is to let it, you know, shut down and be shut down for 5 minutes. All right, when removing the filler cap, what is a cautious action that you want to take? Okay, is it remove it firmly but not aggressively, or remove the top lid on it first, then turn the handle? Okay, it's actually the first answer. Remember I said just do it firmly, but if it's taking you extra effort to do that and you're really forcing it, you do not want to do that. You'll damage it. All right, let's do a couple more and then we'll go and talk a little bit about the temperature sensor. All right, name the order of the lubrication scavenge oil circuit. Okay, is it A, you have the heat exchanger, chip detector, and servo fuel heater, or the chip detector, servo heater, and heat exchanger? Okay, you're getting an order right now. Okay, the answer is actually the second answer. It actually goes through the chip detector, then the servo heater and heat exchanger. Think about this. You got to take any little metal particulates, any little debris like that, needs to get out of the oil before you're going to cool it, before it goes to the oil tank. So, you know, that's the order, not any other order. Okay, how many pumps are used to scavenge the oil after it lubricates its main components? Okay, remember I said there's 4 scavenge pumps. All right, so you got an idea on that. Okay, so let's kind of go a little bit more. Actually, you know, we're going to talk about the temperature sensor, and you can be hanging up on that, right? But I wanted you to understand oil temperature is very important. You know, it can cause damage to components if that oil is too hot. Just in general, as far as just, I mean, there's obviously the aircraft, especially the engines, are made, you know, with the structural integrity of the metal to handle high temperatures. I mean, that's a given. But oil temperature, you know, it needs to be not too hot. So with here you have a single element that's sensing the oil temperature. And we can get into the electrical part of the whole thing, but this element is basically causing the change in the resistance of that. When the temperature changes, then it's going to be sensitive to that and give an indication on the in-cam. The temperature measurement range of this temperature sensor, okay, of this element, is between negative 58 degrees Fahrenheit to 392 degrees Fahrenheit. It's a pretty wide range. Okay, and the oil temperature indicating, only the oil temperature for the engine condition monitoring is indicated, not any other kind of oil or oil anywhere else. It's actually just the oil temperature for the engine condition that's going to show up there on the ECAM through the FWCs. Okay, you have and also the DMC. That advisory level, when you have the oil temperature at a certain just at the advisory level, it's going to be flashing in green. Green means that the temperature of that oil is higher than 284 degrees Fahrenheit. That's pretty hot. Okay, but you know, it is running through there, serving its purpose. But just so you know, it's a flashing green indication when it's greater than 284 degrees Fahrenheit. Now the indication becomes amber, and of course, remember with amber light, you always have that pairing with the master caution light. So the master caution light is going to come on when the temperature is higher than 311 degrees Fahrenheit. So we went from 284 degrees to 311 degrees Fahrenheit, where we have these markers, if you will, of indication and, you know, and warning colors. So we have the flashing of green at 284, and then it becomes amber at 311 degrees, which we know the master caution light will come on at that time. It's going to do, and that's assuming that the temperature goes up to that 311 for 15 minutes. So there, it's lingering. If it just stay for 5 minutes, it's not going to stay on like that. It's not. But if it's lingering, you know, for 15 minutes, that's when it becomes a problem, or something that needs to be addressed. Okay. All right. All right. So they kind of give you an idea there on the actual ECAM for Eng 1, Eng 2. You're going to see that on there, either oil high temp. Okay. So that's the wording on the ECAM. It'll say oil high temp. All right. Now, we also have the engine oil temperature. That was for engine condition, but we also have the engine oil temperature sensor for the IDG cooling system control. So this here, this particular sensor is located above the oil tank and on the oil supply tube that's to the forward bearing sump, and that runs at about the 9 o'clock position. Okay, so this is the difference. This is the engine oil temperature sensor for the IDG cooling system control. This is here a sensor. There's different kinds of sensors. This one in particular is a thermocouple, dual type, I should say, a dual type thermocouple. You have two different metals that are, it's just engineered that way for this purpose. Okay. So anyway, got the details on that. Obviously, if a sensor is considered faulty, has been found to be faulty, we're just going to have to switch that out. Okay. All right. So we have the monitoring, like I mentioned before. You know, on the temperature sensor, this one's located on the oil pressure filter. This is for the engine condition. I know just a bit ago I just mentioned for IDG cooling control. You know, but here on the oil temperature sensor for the engine condition monitoring, this one is located on the oil pressure filter that's downstream of the pressure pump. Okay, oil temperature is sensed by this, you know, sensor, and its range is a little bit. It's it's the same. So negative 58 degrees to 392 degrees. So it's the same, you know, same range as the other sensor. Okay. All right. Okay, that kind of gives you an idea on the sensors. All right, so we talked a little bit about the that we got the quantity, right? So immediately we're talking about, or you got introduced to the quantity, looking at the level of the oil, and then also servicing it, you know, and how to, you know, fill the oil tank up to where it needs to be, minimum quantity, etc., plus extra for, you know, the consumptive aspect, making sure there's enough oil for consumption for the aircraft in flight. Also the pressure transmitter and also the temperature sensors. And now I want to just touch on the magnetic chip detector. The magnetic chip detectors, there's actually 4 of them, and they consist of a sleeve. You've got the magnetic plug assembly, because you need a magnet there to attract the metal particulates that are in the oil, and then also a spool. You've got a metal mesh screen that's spring-loaded, has a spring-loaded pin to lock the screen in position. You have the magnetic bar there to attract, like I said, those magnetic particles that are, in the oil, and so you have that kind of idea there. Just also, the little bit of description on this, on the spool. That spool is installed in a bore of the lubrication unit housing, so that's where you'll find that. And as far as the magnetic plug assembly itself, when you remove it, well, the spring's going to push the spool into the sleeve. Okay, just the way the mechanism is. Okay, and then as far as just examining the chip detector, you need to just be careful that, just pay attention to what's there. You don't want to, also we want to ID it properly. I mentioned that before about serial numbers and making sure that you have identification of the actual chip detector. Okay. All right. And just kind of if you haven't worked on anything with, I've talked to some of you, actually a lot of you, and it seems that at least the majority, the ones I talked to, were structures people, and then there's power plant technicians. So I mean, there's some of you have never even worked on power plant at all, and the reason I bring that up is because in structures you're not dealing with O-rings and seals and not like that. So you need to, with power plant, you've got all these places where you have fluid running, and every time you have fluid, you have to have seals. So here I mentioned that because O-rings can go out depending on which or I guess the quality of them, but O-rings can be really worn just by the nature of what they are there for. So do make sure that you are switching out O-rings, visually inspecting, making sure they're in good condition. Obviously, if they're not, then switch them out, get a new O-ring in those places. Okay, because you don't want to have a loss of oil. Whether there's fuel leaks, oil leaks, nobody wants that, especially the pilot. So, we don't want to have a problem where we have a leak that's causing damage to other components while in flight or otherwise. Okay, all right, that kind of gives you an idea. Covered quite a bit. Wasn't, kind of give you an idea on the supply circuit with scavenge circuit. You have oil from the oil tank. You've got that flow of oil going to through filters that are going to go to lubrication units, basically to distribute through nozzles the oil to the engine bearings, the accessory gearbox, then to the transfer gearbox. So all to those bearings, 1, 2, 3, 4, 5. Okay, and your forward and aft sump of the engine. Also, a little bit on being able to keep the oil clean along the way before it comes back, and also in cooling it. We also talked about pressure, making sure that the oil is at a certain pressure. The supply pressure should be at around 35. Okay, normal operating pressure at roughly 35 psi. Okay, and that roughly comes to about 2.3, 2.4 bar. That's just another unit of measure. Okay, as far as its conversion to that. Okay, let me go ahead and finish out some of these test questions for you. All right, let's kind of go to, I know I didn't mention before, but you're gonna get it now. Okay, what is the indication flash green? Remember I mentioned that green flash as an indication. When the oil temperature is higher than 140 degrees, or when the oil temperature is higher than 125. Okay, roughly. Okay, at some point I was saying 284 degrees Fahrenheit. Okay, this is in Celsius. Celsius is 140 degrees Celsius. But if you see 140 degrees Celsius, that's for Celsius. That's the same as the 284 degrees Fahrenheit. How does the low oil pressure switch get triggered? Okay, is it through 11 psi increasing pressure or 16 psi increasing pressure? Okay, I didn't mention the 16, but I'm mentioning it now. That low oil pressure switch gets triggered at 16. Okay, so just remember that, because oil pressure has to be at a certain level. Remember I said roughly about 35. And it does fluctuate, so it's not a big thing. But if it hits 16 psi, that's quite a deal lower than that 35 psi. So once it hits that 16 estimated increasing pressure, then it's gonna trigger. Okay, that switch is gonna trigger, and there's gonna be an indication for low pressure. All right. Let's see. How about okay? How about this? When does the indication flash amber and the master caution light comes on? Okay. I know I said 311 degrees Fahrenheit. If you see it on the test as Celsius, that's going to be 155 degrees Celsius. I hope you have a pen and paper in your hand right now. Please take notes. Okay, so if you see 155 degrees Celsius, that's the same as the 311 degrees Fahrenheit. Okay, remember I said that there's that green light will come on at 284 degrees Fahrenheit, and then if it gets higher and higher, all the temperature is higher, then you're gonna to 311. That's gonna be the trigger where that amber light is gonna come on, which automatically the master caution light comes on. Okay. All right, where's the oil temperature sensor for the ECU? Okay, this is for the IDG cooling in particular. Is it located at the main oil filter housing of the lubrication system, or above the oil tank on the oil supply tube? Okay, it's the last answer. It's located above the oil tank on the oil supply tube. All right, let's try another one. Where is the oil pressure transmitter and the oil pressure switch located? Okay, is it on the lubrication unit inlet line or on the lubrication unit outlet line? Okay, it is on the outlet line. Okay, when the bypass valve opens in the event of a clogged filter, no maintenance is necessary since the operation continues. Is that true or false? Okay, now sometimes you're going to get a true-false question. Okay, that answer is false. Just because there's a bypass valve that allows, oil to still doesn't go through, doesn't mean that we just ignore the fact that we have a clogged filter. I mean, we have a clogged filter indication on the ECAM. It cannot be ignored. Okay, all right. Let's see. How about one more? Okay, here's one for you. Take notes. When is the scavenge filter clogged? Okay, was it when the differential pressure reaches 25.5 psi or 15.5? All right, you're getting the information right now, so write it down. When is the scavenge filter clogged? Okay, it's actually the first answer. It is clogged when the differential pressure reaches 25.5 psi. Okay. All right. And if you want to learn a lot more detail about any of this, seriously, if you do, let us know. And we'll try also to get more videos out, or just audio, by the way, on specific parts to it. I mean, some of you are actually interested in more of this. Some of you, that's okay if you're not too much into that. You just want to say, I got what I needed. That gives me the familiarity, and I want to move on. It's completely fine too. All right. Okay, so that pretty much does it. I did cover a lot of the practice questions. You will see again. I'm gonna just tell you, you will see it again. If you have questions about maybe you missed an answer or whatever, just email us, and we'll help you through to get that answer for you. All right, well, I enjoyed presenting this to you, and I hope you learned a lot, and I look forward to